On the cosmic clock, the hands move relentlessly toward the end of time. With each passing second, the movement of every atom and particle guides us toward the final chapters of the universe. Among the possible scenarios for the universe's end, one stands out, hidden in the fundamental laws that govern heat, energy, and time, the laws of thermodynamics. These laws suggest that one day, the entire universe will enter a state of heat death, a dull, motionless, and sterile end. But how did we arrive at this idea? Let's rewind to the 19th century. Scientists like Lord Kelvin and Rudolf Clausius discovered the profound implications of the laws of thermodynamics, not just for closed systems, but for the universe as a whole. In 1852, Lord Kelvin was one of the first to suggest that the universe might be moving toward a final state of thermal equilibrium. This idea, known as heat death, puts a new and disconcerting perspective on the fate of the cosmos. To understand how these laws point to the end of the universe, we need to grasp what they are and how they govern energy. The first law of thermodynamics states that energy in an isolated system can neither be created nor destroyed, only transformed. In cosmic terms, this means that while the total amount of energy in the universe is constant, its usefulness can change. Energy can transform into heat, which then spreads out and becomes less available to do work. The second law of thermodynamics is the key to understanding the universe's fate. It states that in an isolated system, entropy, a measure of disorder or energy dispersion, tends to increase over time. This means natural systems evolve toward states of greater disorder and less capacity to do useful work. As time progresses, the entire universe is constantly increasing in entropy. Stars burn their nuclear fuel, transforming useful energy into heat that dissipates into space. Eventually, this process will lead to all energy being evenly distributed, and the universe will reach thermal equilibrium. There will be no more energy gradients to fuel stars, planets, or any form of motion or life. Lastly, the third law of thermodynamics states that as a system's temperature approaches absolute zero, its entropy reaches a constant minimum value. Although absolute zero is theoretically unattainable, this law suggests that as the universe approaches its heat death, the temperature will get very close to absolute zero. In this final state, the universe will be a vast, cold void where entropy is maximized and nothing more can happen. All stars will have turned off, black holes will have evaporated, and all matter will have dispersed. No temperature differences will remain, and no thermodynamic processes can occur. In this scenario, all energy will be present, but useless, incapable of doing any work or sustaining life. This final state will be the natural result of the inexorable action of the laws of thermodynamics over trillions of years. So, as unsettling as it may be, the laws of thermodynamics not only govern our everyday lives, but also hold the key to understanding the eventual fate of our universe.